The Pre-Calc Honors team decided to look at 6-5 after spring break, and this week we'll focus on 6-6. To introduce today's topic, we have to take a look back at imaginary numbers. Back in Algebra 2 with trig, you guys were asked to graph a complex number. If you forgot, a complex number has both a real part and an imaginary part. When graphing a complex number, we graph the real part on the x-axis and the imaginary part on the y-axis. Notice that when I graph this, I'm really going to be thinking about this ordered pair 3, -4. Now you may say, what happened with the I? Well, we let the y-axis represent all the imaginary numbers. I always remember this because you can actually make a giant capital I out of it, which reminded me that this is where the imaginary numbers were represented. So if I ask you to graph the complex number 3 minus 4i, you're really just graphing 3 on your real axis and then -4 on your y-axis, and you'd be talking about this point right here. So this would be your, 3 minus 4i coordinate. Now, this will become important for today because we will look at graphing complex numbers. So let me generalize it first, and then I'll show you how we're going to go about doing this. So here is the general form of this, where you will see I labeled the sides of this triangle created from graphing this ordered pair a plus bi, with an a representing the x-coordinate, a b representing the y-coordinate, which again would be the imaginary part of this complex number, and then again sticking with those r's and thetas that we've been working with. So you guys are going to see that when we're dealing with this, I am going to be showing you guys this new form today, and it's called trig form, where z represents the trig form of a complex number, a plus bi. Now, keep in mind that this form right here is something that looks a little scary, but if you connect it with SOHCAHTOA, it actually isn't that bad at all. If I wanted to represent a using SOHCAHTOA, keep in mind that this is the adjacent side to this angle theta, so I could say that the cosine of theta equals a over r. Or in other words, if I wanted to solve for a, I could say r cosine theta. We have seen this many times over. Sometimes it says equals x. In this case, equals a. Well, note, if I were to sub in what a equals, you're seeing that for a, we would have this r cosine theta. And I can do that same thing for b. Note that if I wanted to find b, I would use sine theta equaling b over r, and then could solve for b by saying r sine theta equals b. Note that when I sub that in for b, I have this imaginary part connected to it. Now, if you look at this trig form, note that it really is very similar to what I have stated here. The only thing is that since both of those terms share an r, I can factor it out, and lo and behold, you will see this trig form. Now, we do shorten this notation, but for right now, let me show you the first few problems using this notation, and then I'll show you how we can shorten it. Same formulas, though, as what we've been doing in 6-4. You'll notice those same two formulas. So if you're asked to write the trig form, the goal of this is to get it to look like what we see boxed up here. So you're going to do this exactly as we've been doing this with 6-4. You can start by thinking about graphing this. Now, remember, when you graph this, we have the real part representing x and the imaginary part being represented by the y value. So this would be equivalent to going over 5 and then down 5. I'm talking about this point right here. But in order to write this in trig form, I need two things. I need this distance here, and we're going to call this our r value, and then I need this angle theta here. So as we've been doing, creating triangles, we have this measurement of 5, -5. I don't want you to confuse what that is. And we want to find our r and theta. So as we've been doing, you can think r squared equals this 5 squared plus the -5 squared. So we get r squared equals 25 plus 25, or 50. And then from there, we can simplify this by taking the square root of both sides. Remember that 50 is 25 and 2, so we have a pair of 5s. So we can rewrite this r value as 5 root 2. Now, to find the angle, as we've been doing, remember that the tangent of theta equals the y value over the x. So if I wanted to find this angle, just like what some of you guys were struggling with the quizzes, do not forget that we are in quadrant 4. So when you think about where's the tangent theta equal to -1 in quadrant 4, it's going to be that middle angle in quadrant 4. Now, what does this trig form look like? We can say z equals, and you're going to put that r value in front, and then in parentheses, you're going to say the cosine of 7 pi over 4 plus I sine 7 pi over 4. And that's it. Now you may say, what happens if I go to cosine 7 pi over 4 and find that value and sine 7 pi over 4? If you find those values and distribute the 5 root 2, you'll get right back to where you started for the original problem. Second problem on here, same idea. Why don't you try it out, pause the video, and then restart the video once you have the solution. Hey, welcome back. So let's see how you did. So for this problem right here, you should have, first of all, found the triangle that this creates. No big deal that this is 2 root 3. I mean, we don't actually have to find that measurement, what that actual value is, but then we can call this 2. And then we have this theta, we have our r. So if you want to find r, you should have said r squared equals 2 root 3 squared plus 2 squared. And then we could have done the product squared. So that would have been 4 times 3, or 12, plus 4. So we get r squared equals 16, square root. We get r equals 4. Now for our angle theta, we're going to say that the tangent of theta equals the y value over the x. So we want to think about where in quadrant 1 do we divide y by x and get a ratio of 1 over root 3. Well, if you recall, we want to make sure we flip the root 3 over 2. So that needs to be our x value. And then our y value needs to be the 1/2. Because when we divide, we're going to flip that second fraction, and that will give us this ratio we want. So we're looking for, where's our ordered pair? Root 3 over 2, 1/2. So long x, short y, we're talking about that angle of pi over 6. Now to conclude, you can write this in this trig form. Z equals, we're going to have the 4, and then we're going to have the cosine pi over 6 plus I sine pi over 6. And then that would be your final answer. Now, at the bottom of this, you will see how we can shorten this expression. Mathematicians are really lazy. We do a lot of higher math problems where you don't want to have to rewrite this every single time. So this expression has been often shortened to this KISS form. I know it doesn't look like KISS. A lot of people will say cis. But because the cosine has a hard sound, that cosine, we go hiss. I don't know. Here I am trying to teach you guys English and how to pronounce words. But you can call it kiss, cis, doesn't matter. But the whole idea of this KISS form is if I were to take the answers I just did, instead of writing it this way, I guarantee you'd rather write it as 5 root 2 KISS 7 pi over 4. And you are totally allowed to do this. These two things mean the same exact thing. So just different notations for the same thing. Same thing here. You can rewrite this as 4 KISS pi over 6, and they mean the same exact thing. So just something to keep in mind that you can use either version. You do need to know both, because sometimes you're given things in this form and you'll have to convert to that, or the other way around. So that is the front page of the notes. I'm going to stop the video here, and then I will create a second video for the backside.